We'll start in 1 minute. We'll continue the final exam review today. You'll have to take the final exam on Newton, and there is a final exam practice on Newton, and it's highly advisable that you take the final exam practice on Newton a couple of times. You can take it as many as 5 times. There is going to be some strict rules about submitting answers to the final exam, and when I get more information about that, I will let you know. Last time we were working on this rational inequality. So we started out with an inequality involving rational expressions. But when solving rational inequalities, we want one side to be 0, so we had to subtract 1 over x from both sides. And then we want a single rational expression with a common denominator, so we found the least common denominator, which is 2x squared, and then we finally were able to get it to a state where we could determine what the endpoints are from the numerator and denominator. The endpoints are +4, -2, and 0. Okay, so we plotted those numbers on the number line, -2, 0, and 4. We have 4 intervals to test. And in the left interval, we can pick x to be -3. And I'll use the factored form of the inequality down here, replace every x with -3. -3 minus 4 is -7. -3 plus 2 is -1. And in the denominator, 2 times the number -3 squared is +18. So this number is +7/18. The inequality is less than or equal to 0. And 7/18 less than or equal to 0 is false. So that means none of the numbers from -infinity to -2 are solutions. In the second interval, we can pick x to be -1. Any number between -2 and 0. In the factored form, replace every x with -1. -1 minus 4 is -5. -1 plus 2 is +1. And in the denominator, 2 times the number -1 squared is +2. Okay, this number is negative, -5/2, less than or equal to 0. This is true. So yes, the numbers between -2 and 0 are solutions. Then in the third interval, pick any number between 0 and 4. We can pick x to be +1. Replace every x with +1. So 1 minus 4 is -3. 1 plus 2 is +3. In the denominator, 2 times 1 squared is 2. This number is negative, and a negative number less than or equal to 0 is true. So the numbers between 0 and 4 are solutions. So you might be surprised that there are two adjacent intervals that are solutions. The reason is that in the denominator we have x squared. So that means that in the vicinity of 0, just to the left of 0 and just to the right of 0, when we square a test point, it's going to be positive when the test point is negative, and it's also going to be positive when the test point is negative. Or, sorry, said that wrong. When the test point is positive, the denominator is positive. When the test point is negative, the denominator is positive. So we get two intervals next to each other that are both solutions. In the fourth interval, we can pick x to be 5 as the test point, and then replace every x with 5. 5 minus 4 is 1. 5 plus 2 is 7. In the denominator, 2 times 5 squared is 50. This is obviously a positive number, but a positive number less than or equal to 0 is false. So none of the numbers from 4 to infinity are solutions. Okay, we have to determine if the endpoints are included or excluded. The endpoint that comes from the denominator, which is 0, that's excluded, because division by 0 is undefined. We always exclude endpoints that come from denominators. So we put a parenthesis opening to the right at 0, but also a parenthesis opening to the left. The other endpoints are included because those endpoints, 4 and -2, come from the numerator, and the inequality is less than or equal to 0. So the other endpoints give us the inequality 0 less than or equal to 0, which is true. So we include -2, and we also include +4. So in this interval from -2 to 4, the only omission is 0 itself. And so the interval notation is bracket -2 comma 0 parenthesis, and then union parenthesis 0 comma 4 bracket. Okay, number 16, solve the system of equations. This is a system of two linear equations. So we can use the elimination method. If we focus on eliminating x, we can multiply every term on both sides of the top equation by 2. I'll just say multiply by 2. And then we can multiply every term on both sides of the bottom equation by -3. So multiply by -3. If I said 3, I was mistaken. Multiply every term on both sides of the bottom equation by -3. Okay, the top equation, multiply both sides by 2. We get 6x plus 16y equals -6. Multiply every term on both sides of the bottom equation by -3. We get -6x minus 15y and equals +9. So as I mentioned, we were trying to eliminate x, and x is eliminated because 6x plus -6x is 0. And then 16y plus -15y is +1y, or y. And then on the right-hand side of the equation, -6 plus 9 is 3. So y equals 3 is the y-coordinate of the solution. And then to find x, we can use any one of those four equations and substitute y in for 3. So I'll use this equation right here, 2x plus 5y equals negative 3, but I'm going to replace y with positive 3. So this is 2x plus 5 times 3 equals negative 3. And 2x plus 15 equals negative 3. Subtract 15 from both sides, 2x equals negative 18, and x equals negative 9. You should be prepared to enter the solution as an ordered pair because the solution is an ordered pair. It has an x coordinate and a y coordinate. So I'll write that the solution is the ordered pair negative 9, 3. Okay, the next problem, number 17. The perimeter of a triangle is 50 feet. One side of the triangle is 4 times the second side. The third side is 14 feet longer than the second side. Find the length of each side. Well, just to help out, I'll just draw a triangle. And the distance around the triangle, the perimeter, is 50 feet. And then it says one side of the triangle is 4 times the second side, and the third side is 14 feet longer than the second side. So we pick a variable. I'll just pick x to be the second side because the other two sides are described in terms of the second side. So the second side's length in feet. So my triangle is obviously not going to be to scale, but I'll just pick this to be the second side. And then it says one side is 4 times the second side. So 4 times x is that side. Then the third side is 14 feet longer than the second side. So that's x plus 14. So I'll just label this to be 4x and this to be x plus 14. Okay, the perimeter is 50 feet. So if we add those 3 sides, x plus 14 plus 4x, that has to add up to 50. So this is a simple equation to solve. Combine the like terms, x plus 4x is 6x. So 6x plus 14 equals 50. Then subtract 14 from both sides, 6x equals 36. Then divide both sides by 6, x equals 6. Okay, so the length of the second side is 6 feet. This side, 4 times x, is 4 times 6 feet, or 24 feet. And then this last side, 6 plus 14, is 20 feet. So that one is a pretty simple problem. Okay, we'll look at the next problem, number 18. Solve the equation. The square root of negative 14c minus 13 minus c equals 0. We want to solve for c. We see that c is inside of a square root. So the first thing we do is add c to both sides because we want the square root of negative 14c minus 13 to be isolated on one side. And then the next thing we do is square both sides. So we're going to square the square root of negative 14c minus 13. And on the right-hand side, we're going to square c. When you square the square root of negative 14c minus 13, you're just left with negative 14c minus 13 equals c squared. This is just a quadratic equation. So we'll make the left-hand side 0 by adding 14c to both sides and also adding 13 to both sides. So we get 0 equals c squared plus 14c plus 13. We can solve this equation by factoring. The two factors are c plus 13 and c plus 1. And so the two solutions to this quadratic equation are c equals negative 13 and c equals negative 1. Okay, but we want to check. So let's replace every c with negative 13 to start with. Okay, so replace this c with negative 13. Negative 14 times negative 13 is positive 182. So the positive square root of 182 minus 13. And the right-hand side is negative 13. Well, we already know that this can't be true. The left-hand side is the positive square root of 169. But to say that it's equal to negative 13 is false. So that means negative 13 cannot be a solution. And the same sort of thing is going to happen when we test c equals negative 1. In this equation, replace every c with negative 1. The square root of negative 14 times negative 1 is positive 14 minus 13. And the positive square root of 14 minus 13 equals negative 1. That's clearly false. The positive square root of 1 equals negative 1 is false. So c equals negative 1 is not a solution either. So this equation has no solution. Has no solution because a positive number can never equal a negative number. If this is a final exam question in Newton, then you would have to use the empty set symbol for your answer. Okay, the next problem, number 19. So this is an equation of a circle. We're not starting out in standard form. So maybe you're wondering, how do you know it's the equation of a circle? Well, there's an x squared term and a y squared term. Even if I didn't have x terms and y terms, and the constant has to be appropriate. But if I have an equation that just has x squared and y squared in it, and I'm adding x squared to y squared, and if it's equal to some positive number, then I know that it's a circle. Okay, so we want to get this into standard form. So we'll rewrite this as x squared plus 2x, leave some space, and then write plus y squared plus 6y. And then we want to subtract 9 from both sides. Okay, we're going to complete the square twice. We'll complete the square once on x squared plus 2x. A second time, we'll complete the square on y squared plus 6y. Hey, when we complete the square on x squared plus 2x, take half of 2, which is 1, and square it. So we're going to add 1 to both sides. Then when we complete the square on y squared plus 6y, take 1/2 of 6 and square it. So 1/2 of 6 is 3. 3 squared is 9, so we add 9 to both sides. And then the next step is the standard equation, x plus 1 squared plus y plus 3 squared. And -9 plus 1 plus 9 is 1. Okay, so the center is the ordered pair -1, -3. And the radius is the positive square root of 1, which is just 1. Okay, I don't have a lot of room to graph this, but so the center is -1, -3. So that's the center, and the radius is 1, so hopefully if you're watching, you can see that. Okay, number 20. Graph the line 2x divided by 3 minus 2y equals -2. But it says graph it using the slope and the y-intercept. Okay, so what we should do is just solve this equation for y, because if I put it into this form, y equals mx plus b, then I know what the slope of the line is. That's when I solve for y, the coefficient of x is the slope. And this number, this plus b, this is the y-coordinate of the y-intercept. Okay, so solve for y. We can start by subtracting 2x divided by 3 from both sides. So I get -2y equals -2x over 3. -2x over 3 is the same as -2/3 times x. And I already have a -2 on the right-hand side. Okay, then we divide every term on both sides by -2, or equivalently, we can multiply both sides by the reciprocal of -2. Either way, -2y divided by -2 is positive 1y, or y. And if I divide -2/3 x by -2, I'll be left with positive 1/3 x. And then -2 divided by -2 is positive 1. Okay, so the slope of this line is positive 1/3. And the y-intercept is the ordered pair 0, 1. You can tell that from either of the equations. When x is 0, the y-coordinate is 1. Okay, so to use the slope and the y-intercept to graph the line, first we plot the y-intercept, the ordered pair 0, 1. It's right there. And then from this point, we can use slope, which is defined as rise over run, to find a second point. Okay, so from this point, which is the y-intercept, I'm going to rise 1. That means move vertically up 1 unit. and run positive 3, which means move to the right 3 units. So we find a second point on the graph, which is the ordered pair 3, 2. And in order to graph a straight line, all I need are 2 points. So I can draw a straight line through those 2 points. You can verify that this point 3, 2 really is a point on this line. You can use either of the equations or any one of those 3 equations. So when x is 3, since 3 is the x coordinate, replace x with 3. Then y equals 1/3 times 3 plus 1. 1/3 times 3 is 1, and 1 plus 1 is 2. So this verifies that when x is 3, y is 2. Okay, the next problem. Find the equation of the line with slope m equals -1 that contains the point 4, -5. So you might need to be reminded of the point slope equation. So I'll just write down the point slope equation formula. That's y minus y1 equals the slope m times the quantity x minus x1. So you can use the point slope equation if you're ever given the slope m, and if you're also given a point whose coordinates are x1, y1. So m is the slope. Okay, so we're given the slope, which is -1, and we're also given the x and y coordinates of a point that's on the line. So in this particular example, m is -1, and our x1, y1 is also given for -5. So the point slope equation, y minus -5 equals -1 times the quantity x minus 4. Okay, if you're writing your answer on paper, well, technically this is an acceptable answer, but if you're going to end up typing it into Newton will probably react negatively if you type it in this way. So you should do a little bit more arithmetic. Y minus -5 is y plus 5. And then -1 times the quantity x minus 4 is -x plus 4. This is more acceptable, but make sure you do whatever the directions say on a Newton final exam problem. If it asks for the slope-intercept form, then you have to subtract 5 from both sides. So you can write y equals -x minus 1. Okay, the next problem, number 22. Find the equation of a line parallel to 4x minus 5y equals -1 that contains the point 5, -4. We know that two lines are parallel if they have the same slope. So we need to find the slope of this line, and then we'll also use the point slope equation once we know what the slope of that line is, because we're given a point that's on the line. Okay, so I'll rewrite the equation of this line, 4x minus 5y equals -1. This is called the standard equation for the straight line. So we want to solve for y. So subtract 4x from both sides. We get negative 5y equals negative 4x minus 1. And then divide every term on both sides by negative 5. And we get y equals positive 4/5 x plus 1/5. So the only thing about this equation that we need is the slope 4/5. So the equation of this new line that's parallel to the given line, it has a slope that's also 4/5 because the two lines are parallel. And then the point that the line passes through, x1, y1, is given to be 5, negative 4. So we write the point slope equation, y minus negative 4 equals the slope 4/5 times the quantity x minus 5. And we should do a little bit more arithmetic. Y minus negative 4 is y plus 4. And then if you distribute multiplication by 4/5, we get y plus 4 equals 4/5 x minus 4. So this is a pretty good option if it's allowed. If you're supposed to write it in slope-intercept form, then you have one more step. The slope-intercept form is y equals 4/5 x minus 8. Okay, the next problem, number 23, classify the system of equations as independent or dependent. Well, a system of two equations is called dependent if the two equations represent the same line. And that's what we have here. The line 7x plus 4y equals 3 is the exact same line as negative 7x minus 4y equals negative 3. If you were to multiply every term on both sides of the bottom equation by negative 1, I'll just say multiply by negative 1, you get the exact same equation as the one above it, 7x plus 4y equals 3. So this is dependent. Another thing about a system of two linear equations that is dependent, if you use the elimination method to solve, if it's dependent, you'll always get both variables to eliminate and a resulting equation that's true. So if you add these two equations as they appear, you get 0 equals 0. So both variables are eliminated and the resulting equation involving numbers is true. So that means it's dependent. So this system has infinitely many solutions. That wasn't part of the problem, but you should know that if two lines in a system are exactly the same line, they have infinitely many solutions, and it's also consistent, even though that wasn't asked. But it might be useful to remember, so this is also consistent. 0 equals 0 is certainly consistent. A number is equal to itself. Okay, number 24, classify the system of equations as consistent or inconsistent. So anytime that a system of two linear equations has one solution or infinitely many solutions, it's consistent. The only time that it's inconsistent is if there is no solution. And with a system of two linear equations, if it's inconsistent, it means the two lines are parallel, which means they have the same slope but different y-intercepts. Okay, so if two lines have different slopes, then the system has exactly one ordered pair solution. So there's a number of ways you can go about concluding that this is consistent. You can solve it, and when you succeed in solving it by getting a single ordered pair, you'll know, oh, it's consistent. Or if you try to solve using the elimination method, well, you'll be able to solve it. And then another way, if the slopes are different, then it's consistent. So you can almost tell by looking. So why don't we go ahead and just solve it, since you need to practice. Multiply every term on both sides of the top equation by -2. I'll just write multiply by -2. And we get -2x minus 12y equals -36. And then I'll leave the bottom equation the same. 2x minus 3y equals 6. So when we add these two equations, the variable x is eliminated. -12y plus -3y is -15y. And -36 plus 6 is -30. Divide both sides by -15, we get y equals 2. So this is already enough information to know that it's consistent because there's a solution. But let's go ahead and find the x-coordinate. In this equation, I'll just replace y with 2 and then solve for x. So 2x, add 6 to both sides, 2x equals 12, and so x equals 6. So the solution is the ordered pair 6, 2. So the system is consistent. Okay, moving on. Number 25. Factor completely. 3v to the fourth minus 768. The greatest common factor of the two terms is 3, so we can factor 3 out. And we get 3 times the quantity v to the fourth minus 256. And now we want to know if we can factor v to the fourth minus 256. Well, note that 256 is a perfect fourth power, because 4 to the fourth equals 256. Another way to think of this, you can think of v to the fourth minus 256 as a difference of squares. So let's just look at v to the fourth minus 256 in isolation. So I'm just going to isolate v to the fourth minus 256. And I'm going to write it as a difference of squares. So v to the fourth is v to the second squared, and 256 is 16 squared. So I'll remind you of the difference of squares factoring formula. difference of squares. So if you have something like m to the second minus n to the second, one of the factors is m minus n, and the other one is m plus n. Okay, so sometimes it feels like these polynomials are camouflaged, but we'll go ahead and factor this as a difference of squares. This is like m squared minus n squared. So one of the factors is v to the second minus 16, and the other factor is v to the second plus 16. And you can verify by multiplying that this is equal to v to the fourth minus 256. Well, we can factor further because v to the second minus 16 is also a difference of squares. This is equivalent to v to the second minus 4 to the second. And then v to the second plus 16, that's a sum of squares. So in this course, we just stop. We don't factor a sum of squares. Even though it can be factored, it involves numbers that are not real numbers. So we just leave the sum of squares alone. But we will factor v to the second minus 16. One of its factors is v minus 4. The other factor is v plus 4. And then multiply that by v to the second plus 16. Okay, remember what we started with. We started with 3 times v to the fourth minus 768. So we have to include the factor 3, and then we'll just write these factors. 3 times v minus 4 times v plus 4 times v to the second plus 16. That is the complete factorization. Okay, the next problem, number 26. Solve the equation 12y plus 5 times 6y minus 3 equals 0. Okay, this is all set up to find the solutions. One side is 0 and the other side is already factored for us. So on this one, just apply the zero product property. If the product of two numbers is 0, then one or the other has to be 0. Apply the zero product property. Oops. Started. Apply the zero product property. Okay, if the product of two factors is 0, then to find the solutions, we set each factor equal to 0. And then we solve each of those equations to find the solutions. If 12y plus 5 is 0, then 12y is negative 5, and then divide both sides by 12. One solution is y equals negative 5/12. To find the other solution, if 6y minus 3 is 0, add 3, 6y is 3, and then divide both sides by 6, y equals 1/2. Okay, the next problem, 27. Solve the equation 3 times p to the third plus 8 times p to the second plus 3 times p equals 0. The first step in factoring, if the greatest common factor of the terms is something besides 1, you want to factor that out. So we'll factor p out, and we get p times 3p to the second plus 8p plus 3 equals 0. So one of the factors is the variable p itself. So when p is 0, that will be one of the solutions. But we want to find the other solutions. So now we'll just focus on 3p to the second plus 8p plus 3, set it equal to 0. Okay, we have the quadratic formula. So let's use the quadratic formula on this one, where a is 3, b is negative 8, and c is positive 3. Okay, so p is equal to negative 8 plus and minus the square root of 8 to the second minus 4 times 3 times 3, all divided by 2 times 3. And then negative 8 plus and minus the square root of some number divided by 6. Okay, so inside the square root, 8 to the second is 64. And we're subtracting 4 times 3 times 3 is we're subtracting 36. Okay, so the solutions are real numbers because the discriminant is positive. So this is negative 8 plus and minus the square root. 64 minus 36 is 28. Hey, we can simplify the square root of 28. The largest factor of 28 that's a perfect square is 4. 4 times 7 is 28. And then the square root of 4 is 2. Okay, so I'll write one of the solutions is p equals 0 because p is a factor. And then the other solutions, negative 8 plus and minus 2 times the square root of 7, all divided by 6. And we should simplify this a little bit more. Every term in the numerator has a common factor of 2, and the denominator has a factor of 2 also. So the other two solutions are negative 4 plus and minus the square root of 7 divided by 3. Okay, and the next problem, number 28, determine the values for which the rational expression is undefined. So any of the a values that make the denominator 0, so we can say the denominator negative 9a to the second plus 48a minus 48. Well, that's not permitted to be 0, so we'll just say not equal to 0. And then notice that each of those 3 terms is divisible by negative 3. So I'm going to divide every term on both sides of this inequality by negative 3. So when I divide by negative 3, I'll get 3a to the second minus 16a plus 16, and 0 divided by negative 3 is still 0. So let's see if we can factor this using the AC method. 3 times 16 is 48. And we want to see if we can find two numbers that have a product of positive 48 and a sum of negative 16. So both have to be negative. So we'll start at the extremes, negative 1 times negative 48, negative 2 times negative 24, negative 3 times negative 16, and negative 4 times negative 12. Those add up to negative 16. So that means we can solve this inequality by factoring. So we'll replace the minus 16a with minus 4a minus 12a plus 16. And then out of the first two terms, we can factor out the greatest common factor, which is a, and 3a minus 4. Then bring down the middle operator. Out of the third and fourth terms, we'll factor out negative 4, and we get 3a minus 4 does not equal 0. So we're almost done. 3a minus 4 times a minus 4. This product does not equal 0. So the other restricted values, or the restricted values, are set that equal to 0, add 4, divide by 3. So a cannot be 4/3, and the other one, a cannot be 4. Okay, that's all we have time for today. Tomorrow we'll pick up from where we left off. We'll start in about a minute. We'll continue the final exam review. The final exam is scheduled on Monday from 3 p.m. to 5 p.m. There are going to be some strict rules about the final that I'll email to you later. That since the final exam has to be taken on the Newton software, it's highly recommended that you take advantage of the final exam practice on Newton. I would advise taking the practice two or three times. You can take it as many as 5 times. Yesterday we were working on this problem, solve the system of equations. The two equations are both linear in 2 variables. So we started out, we multiplied every term on both sides of the top equation by +2. And then we multiplied every term on both sides of the bottom equation by -3. And the focus was to eliminate the variable x. So when we added those 2 equations, the variable x is eliminated, and that enabled us to solve for y. Y equals 3. Okay, then to find the x-coordinate of the solution, we can use any one of those 4 equations. I'll just pick this one right here. So in this equation, I'll replace y with 3. And then solve for x. So 2x plus 15 equals -3. 2x equals -18. And divide both sides by 2, x equals -9. So the solution is in ordered pairs, so you should write it that way. The solution to the system is the ordered pair -9, 3. In parentheses. Okay, number 17, the perimeter of a triangle is 50 feet. One side of the triangle is 4 times the second side. The third side is 14 feet longer than the second side. Find the length of each side. Okay, so there are 3 sides described. One side, second side, and third side. Well, one side and the third side are described in terms of the second side. So the easiest thing, in my opinion, is to assign a variable to represent the length of the second side. So the second side, I'm going to say, is x feet. And then in this sentence, it says one side of the triangle is 4 times the second side. So 4 times x is, for one side, is 4 times x feet. And then the third side is 14 feet longer than the second side. So the third side is x plus 14 feet. And then the perimeter of the triangle is 50 feet. So if we add these three sides, 4x plus x plus x plus 14, that has to add up to the perimeter 50. So I'll just write 4x plus x plus 14 equals 50, and then solve this equation for x. So add up the x terms, 4x plus x is 6x. 6x plus 14 is 50. Subtract 14 from both sides, 6x equals 36. And then divide both sides by 6, x equals 6. Okay, so the one side, then 4 times 6, it's 24 feet. The second side is 6 feet. And then the third side is 6 plus 14, or 20 feet. And then you can verify that those add up to 50 if you want. Okay, the next problem on the final exam review. Solve the equation, the square root of negative 14c minus 13 minus c equals 0. We want to solve for c. We see that c is inside of a square root. So at some point we'll want to square both sides, but before that we want the square root of negative 14c minus 13 to be by itself on one side of the equation. So we're going to add c to both sides to get this equation. And then we'll square both sides. The reason we're squaring both sides is so that we can get rid of the square root. The variable that we want to solve for is inside the square root. So to get it out, we have to square both sides. When you square the square root of negative 14c minus 13, you just get negative 14c minus 13, and the right-hand side is c squared. So if this is a quadratic equation in the variable c, so if we add 14c to both sides and also add 13 to both sides, we get 0 equals c to the second plus 14c plus 13. And we can solve this by factoring. You can, if you don't see how to solve it by factoring, you can always use the quadratic formula. But the two factors are c plus 13 and c plus 1. And so this quadratic equation has two solutions. One is c equals negative 13, and the other one is c equals negative 1. Since the original equation involves the square root, we should check both of those. So let's check c equals negative 13. I'm going to use this equation to check, replace every c with negative 13. So on the inside of this principal square root, this is the positive square root. Negative 14 times negative 13 is positive 182, and then minus 13, and the right-hand side, c, is negative 13. Okay, we already know enough to conclude that there's no solution. The left-hand side is the positive square root of 169, which is positive 13. And 13 equals negative 13 is false. So that means negative 13 cannot be a solution. And then when you check the other candidate, check c equals negative 1, well, the same sort of thing is going to occur. On the left-hand side, we have the positive square root of negative 14 times negative 1, which is positive 14. And the positive square root of 14 minus 13 equals negative 1, or the positive square root of 1 equals negative 1. That's false. So neither is -1 a solution. Okay, so the equation has no solution because a positive number can never equal a negative number. If you have this kind of problem on the Newton final exam, then you will have to use the empty set for the solution. Okay, number 19. Write the circle x squared plus 2x plus y squared plus 6y plus 9 equals 0 in standard form and then graph it. Okay, well, we've seen lots of examples of circles in recent days. So to get it into standard form, we have to complete the square twice in this case. And we'll subtract 9 from both sides. Okay, so in the next step, we'll add 2 numbers to both sides of the equation. And in so doing, we will create perfect square trinomials. So for x squared plus 2x, we take 1/2 of 2 and square it. So 1/2 of 2 is 1, 1 squared is 1, so we add 1 to both sides. For y squared minus 6y, we take 1/2 of 6, which is 3, and square that number. 3 squared is 9, so we add 9 to both sides. And then in the next step, we write the standard equation. X squared plus 2x plus 1 is x plus 1 squared. And then y squared plus 6y plus 9 is y plus 3 squared. And the right-hand side, -9 plus 1 plus 9 is just 1. So we have a circle whose center is the ordered pair -1, -3. And the radius of that circle is the positive square root of 1, which is 1. And then we're supposed to graph this. So in the xy plane, so the center is -1, -3. So it's not part of the circle, but so there's the center and the radius is 1, so we can plot points on the circle and then connect the dots, something like that. On the Newton final exam, if there's a question like this, you'll have to do the same sort of thing you did in lesson 11.1, where you graph a circle. Okay, number 20. Graph 2x divided by 3 minus 2y equals -2 using the slope and y-intercept. Okay, this is a linear equation in 2 variables, x and y. And we're supposed to use the slope and the y-intercept to graph it. So what we'll do is we'll rewrite this so that it's in the slope-intercept form, the y equals mx plus b form. When it's in this form, the coefficient of x is the slope, and this number b is the y-coordinate of the y-intercept. So we'll solve this equation for y. So first, subtract 2x divided by 3 from both sides, and we'll get -2x divided by 3. But note that -2x divided by 3 is the same as -2/3 times x. And then we already have the -2 on the right-hand side. And now we're going to divide every term on both sides by -2. or equivalently, we can multiply both sides of this equation by the reciprocal of -2, which is -1/2. Either way, if we divide both sides by -2, -2y divided by -2 is +1y, or just y. -2/3 x divided by -2 is +1/3 x. And -2 divided by -2 is +1. Okay, so now we can see that the slope is 1/3, and the y-intercept is the ordered pair 0, 1. So in the xy plane, if we plot the y-intercept 0, 1, we can find another point on the line by using the slope. Slope is defined as rise over run. So between points, we have a rise of 1 and a run of 3. So we can find another point on the line from the y-intercept. If we rise 1, that means move up 1. And then if we run 3, that means move to the right 3. So we end up at this point. The coordinates of that point are 3, 2. And in order to graph a straight line, you just need 2 points. Okay, the next page. Find the equation of the line with slope m equals -1 that contains the point 4, -5. Okay, so on this one, this is set up in such a way that we can apply or use the point slope form. So I'll remind you of the point slope form. That is y minus y1 equals m times x minus x1. So when using the point slope form, we're given the slope. If we're given the slope m, and if we're also given a point on the line x1, y1, then we can immediately write down the point slope equation based on or given that information. Okay, so in our example, the slope is given to be -1, and a point on the line is given to be the ordered pair 4, -5. So we can write y minus -5 equals -1 times x minus 4. Okay, so that's a good start, and we'll just do a little bit of arithmetic. Y minus -5 is y plus 5. And -1 times the binomial x minus 4 is -x plus 4. And then just do whatever the directions say to do. If they want the equation in slope-intercept form, then you can subtract 5 from both sides, so y equals -x minus 1. Okay, the next problem, number 22. Find the equation of a line parallel to 4x minus 5y equals -1 that contains the point 5, -4. Okay, so this problem will also, it's not the only way to do it, but in my opinion, the most straightforward thing to do is to use the point slope form again. We want to find the equation of a line that is parallel to this line. So the new line has the same slope as this line, 4x minus 5y equals -1. And that new line also passes through the point 5, -4. So we need to know the slope of that line. So if we solve this equation for y and get it into the slope-intercept form, then we'll know what the slope is. So 4x minus 5y equals negative 1. We're going to solve this equation for y, so we'll subtract 4x from both sides. Negative 5y equals negative 4x minus 1. And then divide every term on both sides by negative 5. And we get y equals positive 4/5 x plus 1/5. Okay, what we're after is the slope. So the new line will also have slope 4/5. So we have the slope m equals 4/5. We have the ordered pair x1, y1. That's given to be 5, negative 4. So we can write down the point slope equation again. This time it's y minus negative 4 equals the slope 4/5 times x minus 5. And then do some arithmetic. Y minus negative 4 is y plus 4. And if we distribute multiplication by 4/5, we get y plus 4 equals 4/5 x minus 4. Okay, if the directions call for the slope-intercept form, then we have one more step, subtract 4 from both sides, and we get y equals 4/5 x minus 8. Okay, the next problem, number 23, classify the system of equations as independent or dependent. A system of two linear equations is dependent if the two lines are exactly the same line. And you can pretty much tell by looking that the two lines are the same. If you multiply every term on both sides of the bottom equation by negative 1, then the result is exactly the same equation that is above it, which is 7x plus 4y equals 3. Okay, so that's the only time that a system is dependent, is if the two lines are the same line. But sometimes, well, like this, they tried to camouflage the fact that the two lines are the same. Okay, another way to determine that a system is dependent is if, when using the elimination method, if both of the variables are eliminated instead of just one, and if the resulting equation involving numbers is true, then you know that it's dependent. So this system, if you apply the elimination method, this is all set up to just add the two equations. 7x plus negative 7x is 0, and 4y plus negative 4y is 0, so 0 plus 0. The right-hand side, 3 plus negative 3 is 0. So that's certainly true. Both variables are eliminated, and the resulting equation involving numbers is true, so that means dependent. It also means, even though it's not asking for it in this one, it also means that it's consistent. Because the system has infinitely many solutions. So anytime that a system of two linear equations has either infinitely many solutions or just one ordered pair solution, then it's consistent. Okay, the next problem Number 24, classify the system of equations as consistent or inconsistent. The only time that a system of two linear equations is inconsistent is if there is no solution. And a system of two linear equations has no solution if the two lines are parallel, which means that they have the same slope but different y-intercepts. So graphically, it means that the two lines do not intersect. Okay, another way to answer the question, if two lines have different slopes, then it means that they are consistent because two lines with different slopes will intersect at exactly one point. So the system has exactly one solution. So it's consistent. And you can almost tell by looking that the slopes of these two lines are different. So it's consistent. But you can rewrite each of those two equations in slope-intercept form. So solve the top equation for y. First, subtract x from both sides. And then divide both sides, every term on both sides by 6, so you get y equals negative 1/6 x plus 3. Solve the bottom equation for y. So first subtract 2x from both sides, and then divide every term on both sides by negative 3. You get y equals positive 2/3 x minus 2. Since the slopes are different, that means the lines intersect at exactly one point, one ordered pair, and so the system is consistent. The word independent would also go with this. If two lines are different, or if they have different slopes, it's independent. Okay, the next problem factor completely v times v to the fourth minus 768. The greatest common factor of the two terms is 3, so we have to factor 3 out. So 3 times v to the fourth minus 256. And now the question is, can we factor v to the fourth minus 256? The answer is yes. So v to the fourth, let's isolate that for now, just to focus on v to the fourth minus 256. This is one of the interpretations is that it's a difference of squares. So if you square v to the second, that's equivalent to v to the fourth. And 256 is a perfect square. It's equal to 16 to the second. Okay, so I'll remind you of the difference of squares factoring formula, difference of squares. If you have m to the second minus n to the second, it's called a difference of two squares because you're subtracting one thing squared from another thing squared. One factor is m minus n. The other factor is m plus n. Okay, so we can factor this difference of squares over here. One of the factors will be v to the second minus 16. The other will be v to the second plus 16. And we can factor further because v to the second minus 16 is also a difference of squares. 16 is the same as 4 squared. The other factor, v to the second plus 16, that's a sum of squares. And in this course, we don't factor a sum of squares. It can be factored, but it involves using numbers that are not real numbers. So we just say v to the second plus 16. We cannot factor it using real numbers, so we're just going to leave it as a sum of squares. Okay, but v to the second minus 16, that's v to the second minus 4 to the second. That's a difference of squares, so that can be factored as v minus 4 times v plus 4. And then we're multiplying that by the sum of squares, whoops, v to the second plus 16. Okay, but remember where we started. We started with this. So 3v to the fourth minus 768. We have to include the factor 3. And then we'll just write down these factors. 3 times v minus 4 times v plus 4 times v to the second plus 16. This is the complete factorization. Okay, number 26, solve the equation 12y plus 5 times 6y minus 3 equals 0. Well, this is all set up for us to find the solutions. One side is 0 and the other side is already factored for us. So now we can just apply the zero product property. If the product of two terms is 0, then the way that we find the solutions is to set each of the factors equal to 0 and then solve for the variable. So if 12y plus 5 is 0, subtract 5, so 12y equals negative 5, then divide both sides by 12, y equals negative 5/12. That's one of the solutions. For the other equation, start by adding 3 to both sides, 6y equals 3, and then divide both sides by 6, y equals 1/2, because 3 divided by 6 is 1/2. Okay, the next problem, number 27, solve this equation for the variable p. 3 times p to the third plus 8 times p to the second plus 3 times p equals 0. Well, first note that the greatest common factor of each of the three terms is the variable p. So we have to factor that out. And so now we know what one of the solutions is. Since one of the factors is p, then p equals 0 is a solution. You can see that from this original equation. Replace p with 0, you get 0 equals 0. So we want to find the other solutions. So now we have to determine what we get when we set 3p to the second plus 8p plus 3 equals 0. So here I'll just mention that p equals 0 is one solution. It's one solution. To find the remaining solutions, we have to solve 3p to the second plus 8p plus 3 equals 0. So we can use the quadratic formula where a is 3, b is 8, and c is 3. Okay, so p is equal to negative 8 plus and minus the square root of 8 to the second minus 4 times 3 times 3, all divided by 2 times 3. Then some arithmetic. P equals negative 8 plus and minus the square root of 64 minus 36. 64 minus 36 is 28. So we have the square root of positive 28, all divided by 2 times 3, or 6. Okay, we can simplify the square root of 28. The largest factor of 28 that's a perfect square is 4. 4 times 7 is 28. So P equals negative 8 plus and minus the square root of 4 is 2. So negative 8 plus and minus 2 times the square root of 7, all divided by 6. And then the greatest common factor of every term in the numerator and the denominator is 2. So we'll cancel the common factor of 2, and we get P equals negative 4 plus and minus the square root of 7, all divided by 6. Sorry, all divided by 3. Okay, so we'll all list the solutions separately. We already observed that P equals 0 is a solution. And then the solution that we get here by subtracting is negative 4 minus the square root of 7 divided by 3. And the other one is P equals negative 4 plus the square root of 7, all divided by 3. Okay, number 28. Determine the values for which the rational expression is undefined. So the denominator, any a value that makes the denominator 0 is a value for which that rational expression is undefined. So we'll focus on the denominator, negative 9a to the second plus 48a minus 48. Well, we say that the denominator can't be 0, so I'll say that that's not equal to 0. So this is just a quadratic expression. So notice that negative 3 divides evenly into all of those numbers. And if I divide the right-hand side by negative 3, I still get 0. So I'm going to divide every term on both sides of this inequality by negative 3. And I'll get 3a to the second minus 16a plus 16. Okay, we can solve this by factoring. So let's use the AC method. So we multiply 3 times 16, and we get positive 48. And we want to find two integers that have a product of positive 48 and a sum of negative 16. If the product of two numbers is positive and the sum is negative, then the two numbers have to be negative. So let's go through the systematic process. At the extremes, we have negative 1 times negative 48. Those add up to negative 49. Then negative 2 times negative 24. Negative 3 times negative 16. Those add up to negative 19, so we're getting closer. And then negative 4 times negative 12. Those numbers do add up to negative 16. So we transform the trinomial into a quadrinomial, 3a to the second minus 12a minus 4a plus 16 does not equal 0. Then factor by grouping. Out of the first two terms, we can factor 3a out, and the other one is a minus 4. Bring down the minus sign, and then out of negative 4a plus 16, we can factor out negative 4. So factor negative 4 out of those two terms, we're left with a minus 4. And then a minus 4 times 3a minus 4 does not equal 0. So the restricted values are positive 4 for a and also positive 4/3. So you could say the values that we're looking for which the rational expression is undefined, are 4 and the other one is 4/3. Okay, the next problem solved the equation with rational expressions. Okay, so solve 3 divided by x squared minus 5x minus 6 plus 3 divided by x squared minus 7x plus 6 equals 6 divided by x squared minus 1. Okay, we want to factor the denominators so that we can more easily find the least common denominator. So I'm going to rewrite the equation over here with the denominators factored. So this denominator, x squared minus 5x minus 6, the two factors of that are x minus 6 and x plus 1. And then the next term, 3 over x squared minus 6x plus 6, the numerator is 3. And when we factor the denominator, we get x minus 6 times x minus 1. And then on the right-hand side, 6 divided by x squared minus 1. X squared minus 1 is a difference of squares, so its factors are x minus 1 and x plus 1. Okay, so now we can identify the least common denominator. So x minus 6 is one of the factors in two denominators, so the least common denominator has to have x minus 6. Two of the denominators have a factor of x plus 1, so x plus 1 is also a factor in the least common denominator. And then another factor is x minus 1. Okay, so that's the least common denominator. And what we're going to do is we're going to multiply the least common denominator by each of the three terms on both sides of that equation. Okay, so notice when we multiply 3 over x minus 6 times x plus 1 times the least common denominator, the denominators will be cleared because the x minus 6 factors cancel and the x plus 1 factors cancel. So we'll just be left with 3 times x minus 1 Then we multiply the next term, 3 over x minus 6 times x minus 1 times the least common denominator. This time, x minus 6 cancels with x minus 6, and x minus 1 cancels with x minus 1. So we're just left with plus 3 times x plus 1. Then on the right-hand side, 6 over x minus 1 times x plus 1 times the least common denominator. So this time the x minus 1 factors cancel and the x plus 1 factors cancel. And the things that survive are 6 times x minus 6. So we've succeeded in clearing the denominators. Now we have a pretty simple equation to solve. So multiply 3 times x minus 1, we get 3x minus 3, and then 3 times x plus 1 is plus 3x plus 3. And on the right-hand side, we get 6x minus 36. Okay, so combine the like terms. On the right-hand side, we get 6x plus 0 equals 6x minus 36. And then subtract 6x from both sides, we get 0 equals negative 36. Well, that's clearly false. So, unless I made a mistake, if we get a false result like this, that means the equation has no solution. So for now, we'll go with no solution. I'll double check that, and then if I made a mistake, I'll let you know first thing tomorrow. Okay, let's get started on the next problem. So number 30, Mary takes a sightseeing tour on a helicopter that can fly 450 miles against a 35 mile per hour headwind. In the same amount of time, it can travel 702 miles with a 35 mile per hour tailwind. Find the speed of the helicopter. Okay, so this problem involves equations that have the form rate times time equals distance. And there are 2 scenarios described. The helicopter flies against the wind in one case. I'll just write against wind. And in the other one, the helicopter flies with the wind. We're told what the wind speed is. The wind speed is always 35 miles per hour in this problem. We're given the 2 distances, 450 miles against the wind and 702 miles is the distance flying with the wind. And we're also told some important information. The 2 amounts of time are the same, so that's an important detail to take note of. And we're supposed to find the speed of the helicopter. So I'll just pick capital H to be the speed of the helicopter in miles per hour. Okay, so we have enough time to at least write the equations. So against the wind, the helicopter is traveling at h minus 35 miles per hour because it's flying into the headwind, multiplied by a certain amount of time, and the distance is 450 miles. When it's flying with the wind, the helicopter will be traveling at H plus 35 miles per hour because it's with the wind. And in the same amount of time that it flew 450 miles against the wind, it flies 702 miles with the wind. So as I pointed out, the two amounts of time are the same. So if we solve each equation for the time, against the wind, the time is distance divided by rate, 450 miles divided by h minus 35 miles per hour. And then solve the other equation for time, 702 divided by h plus 35. And we still have a few seconds left. So the two times are the same. So the equation that we want to solve for h is 450 divided by h minus 35 equals 702 divided by h plus 35. Okay, we're out of time now, so tomorrow we'll start by solving this equation for h. That's all for today.